In this video, we're going to look at an application of binomial expansion. And that application is to calculate, or most of the time estimate, the value of powers of decimals. So first of all, find the first four terms of 1 minus x to the 5. So we can use our binomial theorem to work this out. We start with 5, 0. We take the first term to the power of 5, and the second term to the power of 0, and then add on to that 5, 1. First term to the power of 4, second term to the power of 1, plus third term is 5, 2, times first term to the power of 3, second term to the power of 2, plus fourth term, 5, 3, that's the first term, 1 to the power of 2, second term minus x cubed, and then working all that out, we get 1 minus 5x plus 10x squared minus 10x cubed. So that's the expansion. And then in part B, it says hence, remember the word hence means we have to use the previous part, hence, using the value x equals 0.02, estimate the value of 0.98 to the 5. Now this works because 0.98 to the 5 is equal to 1 minus 0.02 to the 5. But this 1 minus a number to the 5 is the same as our expansion that we did in part A. So every time we saw x, we can replace it with 0.02 because instead of x, we're using the number 0.02. So we can use this to do an estimate. We're not doing the whole thing, so it's an estimate, so it's approximately equal to 1 minus 5 times 0.02 plus 10 times 0.02 squared minus 10 times 0.02 cubed. Now we can work each of these out. So it's 1 minus, well, 5 times by 0.02 is 0.1 plus 0.02 squared is 0.0004, 4 decimal places, and when we times that by 10, it's 0.004 minus 0.02 cubed, we get 6 decimal places ending in an 8, 0.000008, times that by 10, we get 0.00008. Now we work that out. 1 minus 0.1 gives us 0.9, plus 0.04 gives us 0, that would be 4, but then we need to minus the 0.00008, gives us 392. So that is an approximation for 0.98 to the 5. If we had used the whole expansion, all 6 terms, instead of just the first 4, we would have got the exact value. And if we type the value into our calculator, if we type 0.98 to the 5 in our calculator, we get 0.9039207968. We notice that our answer is the same to the first 5 decimal places. So it's correct to 5 decimal places. If we think of it as a percentage error on the actual thing, we're actually only getting a 0.0797% error on the actual value. So this is a very good estimate. It's less than 0.1% from the actual amount. A very good estimate indeed. So let's have a look at another example. By using an appropriate value of x and the first four terms of the expansion, 1 plus 3x to the 9, estimate the value of 1.003 to the 9. So the first thing we need to do is expand this. 1 plus 3x to the 9. So when we do that, we get 9, 0. We're after the first four terms, so 9, 0. Get 1 to the 9, 3x to the 0, plus 9, 1, 1 to the 8, 3x to the 1, plus 9, 2, 1 to the 7, 3x squared, plus 9, 3, 1 to the 6, 3x cubed. When we work that out, we get 1 plus 27x plus 324x squared plus 2268x cubed. So that's our expansion. Now we need to find what value of x do we need to substitute. Well, we want 1.003 to the 9, and we've got 1 plus 3 times by something to the 9. Well, the something that we're going to have to multiply by here is clearly 0.001. 1 plus 3 times 0.001 is equal to 1.003. So in this case, we're using x is equal to 0.001, and that is approximately equal to 1 plus 27 times 001 plus 324 times 0.001 squared plus 2268 times 0.001 cubed. That is equal to 1 plus 0.027 plus 0.00324 plus 0.0000268, which gives us an answer of 1.0113628. In this case, the percentage error is 0.0000001%. So this is very, very accurate for 1.003 to the power of 9. And this is one of the main uses of the binomial theorem, particularly in the days before calculators, because you could do most of this work without